So now we are combining gas laws and stoichiometry. Now, don't be scared of this. It's something that we can do. We just got to take our time, follow the steps, and it's really no different than what we've been doing up to this point. So in this problem, we're trying to figure out what volume of nitrogen we need, because usually, we'll get nitrogen in a tank. We want to know how much there is at standard temperature and pressure to react with 0.1 moles of hydrogen in this particular reaction. So in this case, if we're looking for nitrogen, a volume of nitrogen, we're probably going to end up using the ideal gas law here. You might think, okay, combined gas law, we have two different gases, but ultimately they don't tell us anything about the hydrogen except how many moles there are, which is actually really helpful. Because remember, in stoichiometry, the first thing we need to know is how many moles of something you have. You can't do a stoichiometry problem unless you know that. So I have 0.1 moles of hydrogen. And the first question you should ask is, how much nitrogen will be required to react with that? And looking at this equation, we see it's a 3-to-1 ratio. So that means that for every 3 moles of hydrogen, we are going to require 1 mole of nitrogen. So basically, it will require 0.1 divided by 3. It will be 0.033 moles of nitrogen are going to be required to make this reaction happen. But we don't get nitrogen by the mole. In this case, we're getting it in a tank by volume. And it's at standard temperature and pressure. So this right here is our N. This is how many moles we need. And we know it's at STP, so that means we know the temperature of the gas is 0 Celsius, or 273 Kelvin. And we know the pressure of the gas is 1 atmosphere. So essentially, we're asked to figure out the volume. So this should start to look familiar. We know the moles of the gas we want. We know the temperature. We know the pressure. We just don't know the volume of the gas we want. So using our ideal gas law, PV equals nRT, we know V equals nRT divided by P. So the volume of gas we need is 0.033 moles times 0.0821, and liters, atmospheres over moles, Kelvin. I'm getting kind of lazy with the units at this point. I really shouldn't, but there you go. Times 273 Kelvin, all divided by the pressure, which is 1 atmosphere. So if I now calculate this out, 0.033 times 0.0821 times 273 divided by 1, I get volume is 0.74. Remember, the units, if I do this out, will be in liters. So that is how many liters of nitrogen gas can react with 0.1 moles of hydrogen at standard temperature and pressure. If the conditions were different, if say this was 2 atmospheres of pressure, this volume would be different. So it's really important that we specify that. An alternative way to do this problem, it's a shortcut, is you should know that at STP, this is something that comes up frequently, every gas takes up 22.4 liters for every mole at standard temperature and pressure. It doesn't matter what the gas is, 1 mole of gas takes up 22.4 liters. So alternatively, if you remembered this, it's not necessary, you can do it this way, but if you remembered that, you could say, okay, I have 0.033 moles of nitrogen, and I can say for every mole of that nitrogen, so let me just erase this for a moment so we can see that. For every mole of that nitrogen at STP, there are 22.4 liters. So 0.033 times 22.4, I get 0.74 liters, the same answer. So that's a good shortcut, but only if it's at STP. If it's not at STP, you cannot do this. But either way will work in this case. All right, so until next time, I am Derek Genova. Have a delightful day.